Good afternoon and welcome back to Dr. Thalassemia's Fun with Blood. And this is the last test we're going to do for this particular lab. And I'm going to put on my goggles first because I don't want sheep blood in my eye or any of this nasty stuff. And by nasty, I do mean nasty. This particular solution here, it's covered up with aluminum foil, so you can't read it. It's mostly water, but the active ingredient in there is potassium cyanide. So as a reminder, this is why we have rules in lab. No eating, no drinking. This is yellow in color. You can't see it right now. It looks like lemonade or Gatorade. But you want to be careful, because if you mistook it for lemonade or Gatorade, it might be the last mistake of your life. That's why we have rules in lab for safety. So the first thing I need to do is get some of this stuff into a test tube, and then I'll explain it a little bit more as I go through it. Taking the lid off, test tube, big old pipette. This is graduated to 5 mLs. I'm going to go almost to the top. I really only need 4 mLs of this nasty cyanide solution. I'm going to stick it in here carefully. I don't really want it on my hands and my fingers, even my gloves. So I inject that with the plunger. There's my 4 mLs of cyanide solution. See? Yellowish colored. Looks like Gatorade or maybe urine, depending on your imagination. So the next thing I want to do is I want to add blood to this. So I'm going to bring it over this away for the next phase, like so. And you might be thinking to yourself, this is sheep's blood. Why do we have to use a cyanide solution? Because we're pretty sure the sheep is already dead. Why bother to use the cyanide? And that's to get the hemoglobin all into one particular form. You know, hemoglobin, it absorbs oxygen. It can change color depending on how much oxygen or how much CO2, heaven help you, carbon monoxide is in your blood. To do an accurate test, we want the hemoglobin all in one form, just one version of it, not 3 different versions. That's why we have the cyanide. Okay, so for the next part of this, moving this over just a little bit here, this requires a small, cute little micropipetter. And I'm going to use a different one. The way that you do this, traditionally, the pipette tips, they stay in this little plastic container that can even be sterilized and autoclaved. You take the pipetter, you take that out first, and then you bring the pipetter to the pipette, like this. So you're not handling it too much. And I lift the pipetter out like so, and now it's got the tip on it thusly. Alrighty. The next little bit of business is we have to get blood into the pipetter, and then we have to get blood down there into the cyanide solution. Occurs to me I should probably put this in a test tube rack so I don't spill the cyanide all over the place. Right. So I'm picking this up again. And now it's a question of getting the right amount of blood. You go over there. Into this pipette. Fortunately, it's pretty easy. You just push it down to the first stop. Not all the way, not really hard. The first stop. It's calibrated. That'll suck up the right amount, which is 20 milliliters. Excuse me, 20 microliters. We come over here like this. Insert the tip carefully. Release our thumb. Pull the blood out carefully in our pipette. The next trick is I have to get my cyanide ready, like so. And this is a trick. We want to thread the needle. The idea is we don't want this blood, because it's just a small amount, all over the side of the test tube. It'd be a bloody mess. Instead, we want the blood down there in our cyanide solution. So we have to thread this in very slowly and carefully. I'm putting it all the way down into the solution. I'm watching it as far as I can. Pushing on the plunger all the way down, really hard, boom, eject. I'm going to pull it out like so. Put it in a test tube so it doesn't drip all over the place. And now you can probably see we got some blood in there, but it's not mixed. So what we do is the usual way we mix things in lab. We hold this tight at the top, and we mix this carefully just by using our forefinger. And this is why it's good to have goggles and gloves in case you make a little mistake. And sure enough, now it looks like diluted blood. The next step is to let it sit and stew for a while. Yes, it's diluted blood, but we have to let it react for a while with the cyanide solution. Since we don't expect to get clinical numbers in my demonstration, I'm just going to fast forward a little bit. I'm going to fast forward over here. This is a plastic thing. It's called a cuvette. And what I'm going to do, if I can get past this blood, is pour this bloody solution with the cyanide into the cuvette like so. Carefully, because it contains blood and cyanide, both of which are not necessarily good for your health. There we go. Now I got it. As you can see, the whole bloody thing is full. And now I'm going to put it into this gizmo over here. This is called a spectrophotometer. And so what I do is I just carefully, because it's full, I'm moving it over here, opening the lid. I've already got it set up and calibrated, so it's warmed up, it's good to go. This is my blank that I calibrated it for. Now I put in my cuvette with the blood and solution. I push it down into the machine so it's nice and snug. I close the lid to keep out all this extraneous light. And then I look at the number. You might not be able to read it, but I can read it even upside down. It says 540 nanometers. That's the wavelength of light I chose. But the most important thing, it says 0.346 A. A means absorbance. That's what we're looking for. This machine is measuring the absorbance of the blood, or actually the absorbance of light by the hemoglobin in the blood. Because everybody knows blood is red. That can only mean one thing. It reflects the red light, it absorbs the blue light. If I set this to the right wavelength and stuff, I can quantify just how red it is. Like I said before, it's more brighter red if it has a lot of oxygen. It's less red and it's darker if it has less oxygen. We want to get rid of those variables. That's why we use the cyanide. But then this machine will give us an exact number. Because if you just look at it, even if you got a good background, it doesn't matter if it's white paper, black paper, you can't really make a good judgment. Oh, I think it's pretty red, I think it's okay. Or I think it's too light. Oh, no, it's not okay. So instead, what we need is a scientific numerical reading, then we can make our judgment. But our judgment involves this number. And that's just the beginning point. You start with this number and then you make calculations. I'll give you the numbers and the calculation, the formula is in your lab handout. But this, to remind you, this is just the absorbance. How much light does that blood absorb? From there, then we do calculations and we calculate, okay, that's how much light the hemoglobin absorbs. Therefore, what is the hemoglobin concentration of the blood? That's what we want to know. In terms of diagnosing things like anemia, we have to get a numerical version of the hemoglobin that's in the blood. Can't just do it by guesstimating if it's red or not. Okay, so that's the last experiment for the testing of the red blood cells. Thanks for joining me this Friday afternoon. Remember, my name is Dr. Thalassemia, and be sure to recommend this video to all your friends and neighbors.